Okay, Assalamualaikum and salam sejahtera. Konnichiwa. Alright, so this is a new chapter which is called Laplace transform. Okay, so Laplace transform. Okay, so what is Laplace transform? Okay, so the Laplace transform is basically a function. Okay, so we can write the function ft, for example. Okay, so let's say the Laplace transform, okay, of a function ft, alright, is defined by, okay, so this is the notation. Laplace transform of the function ft is fs. Okay, so we use a capital F. Okay, which is what is the definition of the Laplace transform? It is equal to the integration. Okay, equal to the integration from 0 until infinity e minus st multiply with ft subject to dt. Okay, so this is the definition of the Laplace transform. Okay, so we will use this one lah. Okay, the formula will be the integration, okay, subject to dt. Okay, so if we Laplace transform of the small letter f, okay, we will obtain the capital F. Okay, so some books will use the notation like Laplace transform of gt, so we will obtain gs. Okay, so we will use, if you want to use the formula, it will be 0 infinity e minus s is a constant, yeah, t is the variable, g t dt. Okay, so to avoid confusion, we used a function. Laplace is the function is small letter gt or ft. Okay, after the transformation, we'll use the capital letter. Okay, alright. Okay, so now we want to solve an example. Okay. Alright, so let's say example, using the definition of Laplace transform. Okay, find the fs lah. Okay, if our ft is equal to a, alright, where a is any constant. Okay, so the question here is, using the definition of Laplace transform, find fs if the ft is equal to a. Okay, so basically we want to find fs. Okay, so we know that the definition of the fs just now is, okay, the Laplace transform of ft, which is our ft now is the Laplace transform of a, right? Okay, so by using definition, we have from 0 until infinity e minus st ft dt, isn't it? Okay, so we know that our ft is a, so from 0 infinity e minus st multiply with a dt. Okay, so now you need to integrate this. A is a constant, s is a constant, so we will have the integration of this is a e minus st over minus s. Okay, from 0 until infinity. Okay, alright. So this one we can bring it out minus as lah, a over s. So we have the remaining is exponent minus st. Okay, so we will have minus a over s, okay, e minus infinity minus e minus 0. Okay, so e, okay, for this one here, e minus s infinity is basically 1 over e infinity lah. Okay, s multiplied with infinity is infinity, so we will have 0. Okay, how about this one? Okay, e minus 0. Okay, so it's basically 1 over e0, 1 over 1, which is 1. Okay, so our final answer is minus a over s, 0 minus 1. Okay, so will be a over s. Okay, therefore what we can summarize here is the Laplace, we use a different color, a Laplace transform of a is equal to a over s. Okay, so this is what we obtain, right? So this is our formula, okay, that we already proved. Okay, alright, so a over s lah. Okay, so how to prove it? This is how we prove it. Okay, so now let's say, okay, since we already know Laplace transform, we already know that Laplace transform of a, where a is any constant, is equal to a over s. Okay, where s is greater than 0 lah. Okay, so let's say if we want to have like Laplace transform of 1, for example, okay, or let's say we want to find the Laplace transform of minus 3, or let's say we want to find the Laplace transform of half, okay, or any constant lah. Okay, any constant. Okay, so here we know already a is a constant, so Laplace transform of 1 will be 1 over s. Okay, Laplace transform of minus 3 will be minus 3 over s. Okay, so Laplace transform of half will be half s. Okay, alright. Okay, so now let's find the next question. Okay, so we want to find fs, which is fs is equal to the Laplace transform of the ft, right? If ft is equal to the exponent at, where a is a constant. A is constant. Okay. Alright, so how we want to solve that? Okay, so we can use the definition. Okay, we can use the definition. Fs is basically the Laplace transform of ft, where now our ft is EAT. Okay, so we can use the integration from 0 until infinity negative st multiply with ft dt. So this is the formula. Okay, so 0 infinity e minus st. Okay, so we know that the ft is EAT dt. Okay, so now we can merge, since it is exponent with exponent, so it will be 0 infinity e minus s minus a t dt. Okay, so we just take out the negative because that one is the way, okay, the easiest way lah, okay, the tricky way, okay, how we want to substitute infinity later on. Okay, so it is easier for us. Okay, so that's why we take out the negative. Alright, so now we want to integrate the exponent. Okay, so we will have exponent minus s minus a t. So we integrate, that one will be minus s over negative s minus a. Okay, so we integrate it from 0 until infinity. Okay, so what do we have here is we just substituting the infinity and 0. So we will have, so we can take out, right? So we can take out this one, so it's easier. Okay, so we have e minus s minus a t, okay, from 0 infinity. Okay, so we will have negative s minus a, so e negative infinity minus e negative 0. Okay, so we will have negative 1 over s minus a. So again, e negative infinity is 0 and e negative 0 is 1. So negative negative, it will be positive. So 1 over s minus a. So the conclusion is Laplace transform of e a t is equal to 1 over s minus a. So this is what we have. This is what we already proved. Okay, alright, therefore, for example, if we want to have, since we already have apa tadi? Okay, Laplace transform of e a t is equal to 1 over s minus a, where a is a constant. Okay, so we can have Laplace transform of e to t, for example. Okay, so our a is 2 1 over s minus 2. Or let's say we have Laplace transform of e minus 3t. Okay, so our a is minus 3, so s minus 3, which is 1 over s plus 3. Okay, and so on. Okay, alright. So next one is how about finding the Laplace transform of sine a t, where a is a constant. Okay, same thing. Okay, we can use the definition from 0 until infinity. E minus st multiply with the ft dt, where our ft is the sine, sine a t dt. Okay, so for this one is we need to use by parts lah. Okay, in this case we can use by parts. Okay, so you already learn, okay, in math 1. Okay, so you can solve it by yourself. Okay, at the end of the integration here, you will obtain a over s squared plus a squared. Okay, so if for example, if we want to have let's say Laplace transform of sine 3t. Okay, so we know already it is a over s squared plus a squared. So our a here is 3, so 3 over s squared plus 3 squared, which is 3 over s squared plus 9. Okay, alright, so a is referred to the constant. Alright, okay, or let's say you want to find Laplace transform of sine 2t, for example. Okay, so it will be 2 over s squared plus 2 squared, alright, which is 2 over s squared plus 4. Or maybe you want to find just the Laplace transform of sine t. Okay, so it will be 1 over s squared plus 1 squared, which is 1 over s squared plus 1. Okay, alright. So you may try as well. Okay, so you can solve it using the definition. Using the definition of Laplace transform. Typo. Transform to determine fs for the following function. Okay, so for example, let's say the ft is, let's say just now sine, right? So maybe cos at, or maybe the hyperbolic function, for example, sine at, or the ft is cos at. Okay, so you can try to solve, okay, using the definition of the Laplace transform. Okay, alright, so this is 4. Okay, alright, next. How about if we have for example a question like a different range of equation, alright, so the different range of the ft. Okay, so for example, let's say we have so for example, let's say just now is equation 7 equation 7, so now is question 8. Okay, so let's say we have find Laplace of ft, so meaning that find fs lah, or in the other words we can call find fs, which is capital F. Okay, or find the Laplace transform of ft if, okay, if the ft is given by 2 from 0 to 5, 0 from 5 to 10, and E40 from 10 greater than t greater than 10. Okay, let's say we have this. Okay, alright, so we know that the definition of the Laplace transform is 0 infinity e minus s t f t dt, meaning that from 0 until infinity. Okay, so since for this case we have a different range, 0, 5, 5, 10, and t greater than 10, so meaning that we can separate the ft. Okay, so if we want to integrate from 0 to 5, our ft will be 2. Okay, plus, okay, from 5 to 10, our ft become 0. Okay, and then from 10 to infinity, our ft become E4t dt. Okay, alright, so in this case this one is already 0. Okay, no problem. Okay, so now we want to solve for 2 e negative st, so we will obtain 2 we can take out, so we have e minus st over minus s, okay, from 0 to 5. Okay, and this one here, okay, so basically we can make it as e negative s minus 4t. Okay, the same thing lah. Okay, because we have negative st. Okay, so I make it again, okay, so basically we have e negative st plus 4t. Okay, because since we want to substitute in with the infinity there, we can make it as e, we can take out negative, okay, so we can have s minus 4t. Okay, the same thing lah. Alright, so now we have, okay, plus, okay, the integration of this will be e negative s minus 4t over okay, over negative s negative 4, okay, from 10 until infinity. Okay, alright, so now we want to solve it, we need to substitute this one 5 with t. Okay, we continue. Okay, Laplace transform of the ft. Okay, so we have 2, just now is e negative 5s, over negative s minus e negative 0. E negative 0. Okay, maybe negative s we can bring it outside, Okay, alright, tak nampak. Okay, alright, so plus with negative 1 over s minus 4. Okay, okay, which is multiply with negative e negative infinity, e negative infinity minus e negative 10. Okay, negative 10. Is it correct? Negative 10, s minus 4, negative s minus 4, s minus 4, 10. Okay, alright, so basically negative infinity also, basically it is s minus 4 multiply with infinity, so we just make it as an infinity lah. Okay, so now we simplify. Okay, so I make it here. Okay, make it Laplace transform of ft become, okay, so we know that e power of 0 here is 1 over e power of 0, which is 1. Okay, and then we have this one, e negative infinity is equal to 1 over e infinity, which is equal to 0. Okay, so we can use that. So negative 2s e negative 5s. Okay, so negative 1 over s minus 4, negative negative plus e negative s minus 4, 10. Okay, alright, sorry, here is minus 1, Okay, so if we can expand negative 2s e negative 5s, negative negative positive 2 over s plus e negative s minus 4 10 over s minus 4. Okay, so this is the answer. Alright, okay, so basically we can do anything with using the definition of the Laplace transform. Definition of Laplace transform. Okay, alright. So now, basically, okay, you need to get ready with this Laplace transform formula. Okay, so we already done for the this one here, Laplace transform of A before. Okay, so K also is a constant. Okay, so we already have the definition here. Okay, this is Laplace transform table. It will be given it to you in the test, okay, or in the final. Okay, so we already calculate for K. Alright, okay, so the Laplace transform of K is K over S. Okay, so we already done for EAT. Okay, the Laplace transform of EAT is 1 over S minus A. And then we already calculate for sine. Alright, and then you also can calculate for cos. Alright, sine, cos, sine. Alright, so this one 3, 4, 5, 6. Okay, so you can prove. Okay, and then for number 7 here, we have t power of n. Okay, so if we have the Laplace transform of t power of n, it is, okay, for example, t power of 2. Okay, meaning that we will have n factorial, which is n is considered as 2 factorial as 2 plus 1. So meaning that 2 factorial over s cubed. 2 factorial is 2, right? So 2 over s cubed. Okay, so that's how they do it. Okay, so at the moment we can solve until here. Okay, using the definition of the Laplace transform. Okay, so they obtain this table is from the definition of the Laplace transform table. Okay, alright, so now we want to move to the next property.